Hello, I'm Jan Fuchsa from the Colibri company, and I'm going today to show you one of our important products. It is the Potentiostat PTC05 100 EV. It is designed for 5 volts, 100 amps. It is designed for precise EIS measurements and it is water cooled. Let us start with the unpacking. You will get our Potentiostat in such a box, and if we remove the upper part, you will find there a Potentiostat, a quality certificate, and then 2 bags. It contains a current carrying cable. It is a really thick one, and it is designed to maximally lower the inductance. So it contains several pairs of twisted cables. There are 2 voltage sensing probes. Every probe is ended by 2 terminals, plus and minus. These 2 probes are mutually equivalent. There is a power cord, then a USB cable, and then 2 adapters ended by 4mm banana plugs are used to connect to the current carrying cable, which is standardly ended by lugs. Then there are some crocodile connectors, an auxiliary connector, and 2 resistors to check the quality of your measurements. This is the Potentiostat. It is designed for use in the 19 inches racks. Here you can see the front panel with the power button and 3 LEDs, one for error, one for scan and one for output. On the other side of the front panel there is a nice display. You can check the voltages and current on the display while operating the Potentiostat. If we rotate the Potentiostat by 180 degrees, you can see the rear part. This is the most powerful member of the PTC family, therefore it is water cooled. You can see here output and input for the cooling water. Then there is a big connector for the current carrying cable and 2 connectors for the voltage sensing cables. Then there is a USB connector for the communication with the computer and an auxiliary connector. The auxiliary connector can be used for safety reasons, like connecting an emergency stop, etc. And of course there is a connector for the mains. So let us connect now all the cables to the Potentiostat and the Potentiostat with the computer. So let us start with the current carrying cable. It has a very big connector and it is quite easy to connect it. Clip the 2 lugs of the connector, and in the same way it is very easy to disconnect it. So let us return it. So this is the current carrying cable. Now the 2 voltage probes. There are 2 Ethernet connectors and it is in the same way very easy to connect it. So voltage probe 1 and voltage probe 2. There is an USB connector, so let us connect the Potentiostat with the computer. Now to the auxiliary connector we have to connect now this device. In the case when you are needing an emergency stop button, you will connect it here instead of this device. And the power cord to the mains. I will now connect to the potentiostat a lithium-ion battery. I want to stress that this potentiostat is great for working with batteries, fuel cells, electrolyzers, supercaps, etc. I have connected a lithium-ion battery to the potentiostat. This one is a 150 amp hours capacity, plus terminal of the power cable, minus terminal of the power cable, and two terminals of one of the voltage probes. To minimize all the negative effects of mutual inductance, etc., it is best to maximize the distance between the current carrying cable and the voltage sensing cables. And let us now move to the software, and I will show you some of the results from the measurement. Let us perform galvanostatic EIS measurement on the lithium-ion battery which we have already connected. We are already in the galvanostatic mode, and let us go to the EIS settings, and we will perform the measurement from the 1 kHz to 1 Hz with the amplitude of 15 amps. Let us click on the start button. At the beginning of the measurement there is a period of adapting. It takes few seconds, and after it the measurement started. You can see the impedance here and the phase shift, but the most interesting graph is the Nyquist diagram. So let us move to the Nyquist diagram, and you can see here the beautiful elephant-shaped curve of the lithium-ion batteries. So the measurement is almost done. Yeah, it finished now, and you can see here the beautiful result from the measurement.